Hi, everybody. Welcome back to Bimbo Mentality, a podcast where people who do cool things join us and try to teach us about those cool things. My name is Bug. I am joined, as ever, by my mesmerizing co-host, Emma. How are you?
Mesmerizing. Oh my gosh. I'm doing great. I'm having a good night. I am currently tapping into a French red right now. So having a great little Wednesday evening. Yeah.
I am currently tapping into a cup of Folgers with that French vanilla coffee made in it.
Hell yes.
Over in the booth doing producer shit, it's Lilith. How are you, Lilith?
I'm good. I'm tapping into a Portland Clear water. No fluoride, baby, because that's Portland.
I was scared to ask. I was like, is she making a joke about water? And then I was like, wait, what if it's not? And I feel really dumb.
No, I am
So-
Portland. I've joined the Portland Scientology chapter.
Oh my god.
Joining us this week on the podcast is our guest, Quinnie. Quinnie is a mechanical design engineer with 6 years of experience in the machine tool industry. From the first concept to final assembly, she knows every step of the process that brings her machines to life. Welcome to the show, Quinnie. What are you tapping into?
Hi, it's great to be here. I'm also just drinking water.
Okay, all right. We got a little 50 thing going on here. So this is gonna be a cool one because Quinnie, you are the first guest who's joining us on the podcast. Who was a pitch for the show. We've had guests so far. You know, the first slate of guests was kind of friends of the show whose work I was familiar with and invited on. You're the first one to have reached out to us to tell us about what you do and tell us you might have a good material for the show. Which means that I'm going into this completely blind. I don't know this even a little bit about mechanical engineering. So what I did to prepare myself for this podcast is that you had mentioned in your pitch that one of the things you primarily work on is rotary tables. And what I did is I Googled what a rotary table was.
That's great. That's great.
So, and I think I know a little bit about it. Now that I've Googled it. Emma, do you know what a rotary table is?
Isn't that the thing in the Mazda RX-7 engine? I'm pretty sure that's what it is.
Okay. That's another thing I don't know what it is. A Mazda what? It doesn't matter.
It's a car.
Well, I figured that much.
I know, like, I don't know much about cars, but I know that Mazda has a famous engine they put in the RX-7 and the RX-8 called a rotary engine that is like different from the classic like piston engine.
That's a great starting place to get into this. I think you're gonna like really learn what's happening.
Yeah. Okay. So basically, the answer to your question is no. I have no fucking clue what a rotary
That's
table
absolutely
is.
fine.
Great.
We'll take things from scratch here.
Yeah, so as you can tell, Quinnie, we're off to a great start. You've really been set up for success today on this show.
It's yeah. Mechanical engineering is a very male field, and I think some bimbo outreach is crucial.
I really like thinking of it as outreach. I think that it's sort of, we cross boundaries here. I'd even describe it as a sort of like bimbo mission trip.
Right.
So, having heard our introductions, Quinnie, do you feel like you're ready? Do you feel like you're ready to think like a bimbo and sit down and explain to us what the heck a rotary table is?
I think, yeah. I was, putting my notes together for this episode, and I think the way I was going to kind of go about it was talk about the industry I'm in, the machine tool industry, talk about the thing that I design within that industry, and then talk more about like how it's made and what goes into making that.
Okay, that's awesome. Yeah, let me start actually kind of here. Let's start with kind of your experience coming into this field. What interested you about mechanical engineering, and what interested you about rotary tables specifically, which I still don't entirely know what that is.
Well, that's what the podcast is for. So in terms of getting into this field, growing up, I didn't have a lot of toys. I wasn't very athletic. I didn't have a lot of video games or consoles or stuff like that around. And all I really like the big thing I had from a very young age was a bunch of Lego. And so I think from that way, just like, my brain kind of got wired in such a way that it like just doesn't get bored of like putting things together and doing spatial things with objects. So, yeah, when I was going into college, my two candidates for major were mechanical engineering or architecture. So, and this is the path I took. As for the field of um, what I do, that was mainly because leaving college, I did not want to go into aerospace or defense.
Based.
And of the options that were open after that, this was where I ended up.
That's awesome. So you mentioned a little
Mm-hmm.
bit about wanting to talk about the industry. Tell us about that. Tell us about your experiences in the field of mechanical engineering.
Like I said, mechanical engineering is a very male field. Um, that's something that I found as soon as going into my major. That's something I really found in my workplace as well. Um, and the process of transitioning, of course, really shows you that like it's kind of silly that it's that way at all. Um, and so while I've had mostly pleasant experiences with that process, um, it's been interesting. It's definitely an interesting place to have that stage for your life happen. But having a job and a thing to do that like massages your brain and like works so well with the way you like to think, it's been great.
Well, if you think about it, a transition is
Hmm.
just kind of a way of building a, your true self. So in a way,
Absolutely. And there's even some mechanical changes along the way.
I would also say that it's heavily associated with Legos.
Yeah, yeah.
I'm still spinning out that theory. I haven't really made it work yet, but I'm
Maybe
willing to
this will
stake a
help.
claim on it. So we've heard a little bit about your coming of age into the industry,
Hmm.
about your experience just kind of being who you are in the industry. What interests you about the work you do?
I think it's just the way that every day is kind of, some little mechanical spatial problem. The thing that kind of sets mechanical engineering apart from electrical engineering or computer engineering or a lot of other fields is that the work you do and the things that you need to interact with are all physical objects that you can touch at some level. They're not, invisible things like electricity or abstract things like lines of code. They're all very tangible and real.
So I guess this is the part where I have to to I have to admit that I don't entirely know how engineering as a job works. Do you like do the building? Like, do you like what is the actual process by which a thing is designed and built? Do you like do the specs and then also the actual construction?
Right. So, of course, the duties of any engineer are going to vary from workplace to workplace, from product to product. But typically, an engineer is going to make, like you said, those specs, the drawings that define what an object is,
Are they
and
always
then
like on little? Are they always on like big dark blue paper with white lines?
it's tragic that I missed the dark blue paper era. They used to be blueprints, Now it's mainly digital, but yeah,
That's what
that's
they were
exactly
called,
what an
right?
engineer does, right?
I was gonna say, I feel like I know like the plan drawing
Mhm.
stuff is definitely the engineering, but I feel like kind of like you mentioned about like your experience with Lego as a kid. I feel like my friends that are engineers, especially if they're ones that do more physical stuff, like they will oftentimes be like the tinkerers in their real life with hands-on stuff too.
Right.
Is
Yeah.
that accurate usually?
And
Yeah.
that's definitely true because the knowledge that you have to design these things has to come from physical objects at some point. And whatever you design, whatever your, brain and computer come up with together, at some point, a machinist is going to have to create those parts out of metal, and an assembler is going to have to put those metal parts together. And so, as in the blurb when it mentioned that, like, from concept to production, you know, there's part of me in all of that, right?
Could you do the whole process of making a rotary table solo?
Uh, with guidance and help here and there, and examples from other coworkers. Yeah, basically, it's creating a design, getting your design approved, providing assembly team with blueprints and finished parts. And yeah, what I do generally is also, like the first prototype machine will be something that I assemble myself so that even someone who's not like a skilled assembler like knows how things go together, who I can see which things need to be changed, firsthand.
Okay, here's actually a very
Mhm.
important question because I
Okay.
want to see if I can get this a little bit catty because
Okay, yeah.
I think that I want to start a little bit of a like mechanical engineer civil war. Um, are your
Us-
prototypes have you ever made a prototype that's better than the finished product?
um,
Be
I
honest
don't
now.
think no, I don't think so. I think prototypes are where you have the most warts. And
Ah,
there's
So what you're saying is it's complete bullshit that Tony Stark made an arc reactor in a cave by himself.
I think probably the best way I would sort of describe it is that mechanical engineering is the field that's the most himbos. It's filled with a lot of himbos.
Oh my
And
god, it's like the surgeons. Is it the surgeons of engineering?
right, and I think there's this phenomenon that happens with engineering where when you're solving engineering questions, right? The field is about making what you can make with what you have on hand and like doing the best you can with it. So there's and when you do engineering classes in college, a lot of the problems you solve will say like, okay, assume you don't have to worry about this. Assume you don't have to worry about that and use this to get your answer. And a lot of engineers will have no problem making these assumptions of like, I don't need to worry about this. I don't need to worry about that. I've got an answer and I'm confident in it and we're good.
these himbo engineers are they like single or
Well, some aren't.
it's worth going to the mechanical engineer functions that I assume are a thing.
Yeah, yeah, I think so. It's
Just
interesting.
make a
Yeah.
Lex
Are
post.
there mechanical engineer raves or like is that a thing?
No,
Is there a
if
thing
there
waiting for
were,
us here?
I would have found it, but unfortunately not.
Have you ever made any of your rotary table prototypes out of Lego? I'm just trying to understand the process here.
Actually, I've thought about that a lot. Generally not because I try to like leave my work where it is. And when I do Lego outside of work, I'm trying to like relax. So that's a line I kind of haven't crossed yet.
All right, you don't bring the Legos to work, but do you ever build rotary tables at home?
No.
Totally fair. Are you the type then that loves like are you big into like the buy the like several thousand piece Lego sets and have
No.
those or more
I
okay.
had a huge collection when I was young. I sorted it all, it was all very meticulous. And I'm solely digital now. I If I had some physical stuff on hand, I'd have fun with it, but just the space and the time and energy it takes to deal with physical stuff is no longer for me.
Real.
We ended up getting a little bit snarky with it there. Taking it
Yeah, go
back in
for
the
it. Get
general
snarky.
taking it back in the general direction of like actually trying to learn about this cool thing you do.
Mhm.
How much choice did you end up having in the question of what specific things you built? Like was there something, do you like, are there different kind of tracks that engineers, the mechanical engineers can go on, where you kind of picked and chose what you were good at, or was it just a matter of like getting picked for a company and getting assigned to a particular item?
I mean, I think there's as much choice that goes into something like that as there is about anywhere you work, right? There's a lot of necessity that drives what you need to do, but there's also a lot of, drive and passion and conversations you can have with people around you to help shape that. Um, so I think that would also be a good point to sort of jump into just talking about machine tools in general, and you can kind of contextualize my part of that with the way it works with everything.
Yeah, absolutely. Tell us a little bit about that.
Okay, so if I say machine tool, what do you think of? Do you know what a machine
I
tool is?
I not really.
Like a
I
like a saw.
Yeah, like a
That-
drill. Like I
that's
bet a
those
A
are
drill is
both
drill, a
one of them.
saw.
those are both really good places to start, right? So a saw has a cutting edge, right? And it's a tool that you use to take a block of material and shape it into a way that you can use, or shape it into the start of a larger object. And a drill has cutting edges, and you use it to, again, change part of the geometry of a piece of material.
So wait, so hold on. So all right, I was doing a little bit of a jest there because I assumed this
Right.
was like a an engineering term that I didn't know. Machine tool is just like a tool, like what you would find in a toolbox.
Well, no. So those are tools, right? A machine tool is a device where the spatial relationship of that piece of material and that cutting edge are controlled by a machine. So, for
Okay,
example,
cool.
if you have a drill and you're making a hole in something, you're only going to be as accurate as your hand is. If you have a saw and you're sawing something, you're only going to be able to saw things for as long as your arm can go. Your cuts aren't going to be as straight as a machine would do it. So machine tools come in to do these things to material on a scale that can be mass produced and make interchangeable, accurate parts that go all day.
Okay, cool. So it is an actual specific term. I'm really glad to hear that because I was really, really worried that I just put it on microphone that I don't know what a tool is. So I'm very glad to hear that this is an actual term used in the field. Okay, so machine tools are kind of really big saws.
So there's so many different types of machine tool, right? If it's anything where the relationship between a piece of material and a cutting edge are mechanically controlled, there's so many different types of ways to do that. Um, but I'll break it down into like the big two, right? Most of the machine tools that you're going to find that make most of the things around you are going to come into these two types. And the first is called a lathe. Have you heard of a lathe before?
I believe it's a brand of potato chip.
Wait, I thought a lathe was the thing they tell all of us to put down when we predict horrible futures for ourselves.
Right, right. That's like a literary reference, right? To the lathe of heaven.
Okay.
Uh-huh. The
Okay, so
actual
I was right.
Yeah, it's about the same thing, right?
Nailed it.
The
I'm so proud of you.
and Yeah, and so it's this literary reference because it refers to a piece of machinery used to create objects. Um, so think of a potter's wheel, right? You've got your piece of material, it spins around, you move your finger, in such a way to make something nice and cylindrical.
Like in that one really horny movie with what's his name?
Yeah,
Ghost.
right.
Yeah.
Ghost. Was your, Patrick
Ghost.
Swayze.
Ghost, starring Patrick Swayze. Have not seen it.
Right. so a potter's wheel isn't a machine tool, of course, because the relationship between the tool is your finger, and that's not mechanically controlled. Um, but it uses the same principle to create a cylindrical part. You'll have a piece of metal, like a large cylindrical piece of metal. It'll spin it really, really fast, and you'll have a sharp tool that comes in very precisely to cut away little bits of metal until you get something cylindrical that you can use.
Got it. Okay.
Right?
Okay.
So that's
I
the
think I'm
lathe.
getting it.
Right? The other big type of machine tool is going to be called a mill.
Okay. That's like a place where they keep sand or some sod.
It's a
I don't
little
know
bit
what.
different.
I'm
from
gonna
that.
snot.
So, no, I like hearing your ideas and your guesses. Right?
We just gotta stop talking. But
No, I don't think.
Hey, producer
podcast
Lilith,
hosts-
you two do not need to stop talking. That's the podcast.
Yeah, I'm pretty sure we're not allowed to.
Yeah, I will start yelling if you stop talking.
okay.
Okay,
All right,
so
tell us
for
about
a mill,
the mill.
yeah, right. So think of your drill, right? Imagine your drill. Have you seen a drill press before?
Uh,
No.
Okay.
so.
Anyways,
not.
imagine you've got your drill, and you've got your piece of material, and your drill is going to come down and move through your piece of material, and it'll make something like a trough or a pocket or a hole, right?
I know what a trough is. That's what pigs eat out of.
Right.
Got it.
See, I'm learning.
Right. And so you can see how these two types of machine tool have different ways of moving a workpiece and a tool in relation to each other. On the mill, you'll have your piece of material move very slowly and precisely, and your tool is going to spin really fast. On a lathe, your piece of material is going to spin really fast, and your tool will move precisely.
Oh, okay. I see what you're saying. Okay.
Right?
I never
Yeah.
like considered that before. That's
Sometimes
interesting.
tools make
Right.
things fast, and sometimes they make things slow. Is what I'm picking up.
Yeah. So when you see, a cylindrical object that's symmetric, you can think lathe. And if you see something that's maybe rectangular or odd shaped, and it has, irregular features in it, you can think mill.
Okay.
Got it.
Okay.
So which one is a rotary table?
So I'll get to that in a sec.
Sorry, I'm like jumping ahead of my own things. I'm so curious.
No,
Wait, there's
that's
so
great.
much
That's great.
suspense here, though. I feel like
Yeah.
the introduction of the rotary table at the start of the podcast is kind of like when they show you a little hint of who the killer is in a mystery novel.
The
Right.
fireworks factory. When are they gonna get there?
So before
Is that a
I
reference to a movie that I haven't seen?
It's just a term like it's like a. I think it's a term like when are they getting to the fireworks factory? It's like a I don't know. It's an idiom.
Oh, okay. All
I
right.
don't really
It's
know
not
it.
a specific
I don't
reference.
actually know. I think it's a general term. Lilith, bail me out here.
I actually don't know what you're talking about.
Oh god damn it!
Quinnie,
I'm so sorry to
Quinnie, have
say,
you-
Emma.
That's okay.
Quinnie, have you ever heard this term before? When are they getting to the fireworks factory? Does that mean anything to you?
I don't think I've heard that idiom, but in context it makes sense.
Oh my
Okay.
god.
Have you ever do you think they have rotary tables at a fireworks factory?
Probably not.
Actually,
And,
Actually, this is a different question I want to think about. Who makes fireworks? Like, do engineers make fireworks?
at some point,
Surely they're
Basically, there's-
involved.
yeah, at some point, yeah. I mean, so thinking back to like what we said earlier about like an engineer, comes up with these designs, documents like what exactly that design is and like tells other people how to make it. And engineers are only going to be involved in designing a firework as long as there are advances in fireworks. But what an engineer is definitely going to do is they're going to be involved with the factories that would make cardboard tubes to put fireworks in, right? A cardboard tube is going to have some type of machine that makes it. There's going to be chemical engineering involved with making large quantities of gunpowder and all of the, metal salts that give it color.
I lost track. Are we talking about fireworks or rotary tables?
I thought we were talking about fireworks factories.
Okay.
Yeah,
All right,
yeah,
cool.
yeah. We went over to fireworks.
track
We pulled
again.
over for fireworks factories.
No, I remember that. I just lost track of which one we were talking about right there. Dear audience, we've learned a little about fireworks factories today. We'll put that one as an advance sort of post-it note in the what we learned section later.
Okay. Okay, so we've got our mill and our lathe that we understand, where workpiece and tool are mechanically controlled in relation to each other.
Yeah, the lathe is the one that looks normal and the mill's the one that looks freaky.
Sure.
Nailed it.
Okay. So how much do we know about the term CNC?
Quite a lot, but my mom listens to this podcast. Oh my god.
I don't know if, how much I should say. Or
I'm
what.
guessing it's a different kind of CNC.
I think it's a different thing. I'm gonna tell us what you know about CNC.
Well, in this context, this is going to mean...
Let's all talk about CNC.
Good lord!
In this context, CNC stands for Computer Numerical Control. Right.
Oh.
And this just means that there is going to be a computer that controls the motions in this machine tool. So instead of, needing to crank your mill or your lathe to move your tool or your workpiece over, there's going to be a computer that you program that does all that for you.
Okay.
So from here on out, that's what CNC means.
Right.
Got it.
Okay.
So when I start talking about how wonderful CNC is later,
Jesus.
and how much you can do with CNC, and how there's just the sky is the limit with CNC, we're talking about computer numerical control.
Okay. We're
Got
talking
it.
about computer numerical control. All right.
I will
Sorry,
remember that forever.
I got a little distracted. What's computer numerical control again?
So it just means that on your mill and your lathe, instead of using a hand crank or having a machinist manually there to precisely move things over with, cranks and things like that, there's a computer that does all that. So you can program your machine to move your tool in relation to your workpiece and spin and such.
Got it. So you can be much more precise than like a human hand could possibly be.
Right. I mean, so the thing is, like, the machine is already that precise. And so a human hand is...
fair.
So when you use a manual machine, there will be all these little, like, tick marks. So you'll know, okay, I rotate this dial this amount, and I can tell how far I'm going. What a computer does is that it's not going to go too far accidentally. You're like, oh, right? It's not going to do that. It's not going to get bored. It's not going to make any sort of human mishaps.
So in a way,
and you can also program like a progression. So like, I want to do these 20 steps. I don't have to be there watching it.
You don't have to be there watching those steps. It can do that all day, exactly as precise as you started.
Okay.
So like in a way,
and that's...
if you do it by hand, that's sort of the mill of doing it. But if you do it with a computer, that's like the lathe of doing it.
I think that's probably going to be that's going to be a confusing comparison. I wouldn't go with that one.
All right. We're learning. And that was just a little misfire. All right, carry
That's
on.
okay. Yeah, that's right. That's right. Right. So we're clear on CNC.
We're clear on
Yes, Crystal.
computer number controls. Yeah.
Perfect. Okay, so now you were wondering where the rotary table comes in, right?
I'm
Yes.
so curious about the rotary table.
So our lathe is something that spins material really, really fast. So we'll put in a piece of material, it'll spin really, really fast, and we'll use it that way. A
Okay.
rotary table will take our piece of material, our part that we need to work on, and instead of spinning it really, really fast for use in a lathe, it'll spin it really precisely for use in a mill. So a rotary table is generally going to be used with its axis of rotation horizontal. So think about like a wheel and not like a record player. So it's going to be rotating things this way.
Oh, okay.
So if our mill is coming down, we've got our part, we've got our tool that's spinning really fast, it needs to make a hole in something. With our rotary table, we can have it make a hole in one side of a part. We can flip that part all the way over, we can make that same hole, and things like that, right?
Okay.
So we were talking about engines earlier, and you mentioned the rotary engine, and you compared it to like a V engine with the pistons, right?
Wait, we are coming back
So
to the Mazda.
we're coming back.
Full
So
circle. This is an
right,
incredible. There's so much narrative tension in this explanation. I'm excited.
good. So if I say like an engine block, like a V engine block, you have like a picture in your mind, right? Of like those pistons in a V shape. So one of the uses of a rotary table would be to stick your engine block on that rotary table. You'll have your mill head come down. It'll make those row of pistons, 1, 2, 3, 4. Your rotary table will rotate that by that angle between the pistons, and your mill will come down and do those bores again.
Oh.
Huh.
Oh my god, I can't believe we actually tied that into that. That was amazing. Thank you. That's awesome.
I mean, that's kind of the thing about machine tools is that they make, so much of the world around us, and so much of everything that you use and you interact with. If it wasn't handmade, at some point a machine tool probably did something to it.
Like, probably even this wine bottle, I'm guessing.
So the wine bottle would be interesting because it's like molded glass, right? So there probably wouldn't be a tool that's coming in to make that glass, right? Or cutting that glass.
Oh.
But the mold that shaped that, the mold that makes all those wine bottles all the same all the time, a machine tool would be involved with that.
Oh, okay. Okay, that makes sense. I like actually never really considered how much of the stuff that I interact with is probably made by a machine tool.
Right. So Bug, like that bookcase behind you, right? I can see you've got this flat piece of material and you've got holes in there where there are screws and fasteners that go through that.
Right.
And those fasteners have to be in the same spot on the vertical piece as they do on the shelf. So there was definitely a machine tool that came in and drilled those holes right in that same spot and moved on to another piece and did those same holes again.
It's wild how little time I spend thinking about how all of the things around me were made. And I should think about it more because it's really neat. And even though I don't understand it,
right. I mean,
cool
this
to think
part of
about.
yeah, and then part of what this does is it's going to give you the tools to start thinking about that.
So really the secret to understanding something is to wonder about it for a minute. and then think I should figure out that thing. That's sort of how all of thought works.
Yeah.
So, like, curiosity is a necessary component to be an engineer.
Curiosity is in and of itself a kind of engineering, as you engineer your thoughts and wonderment and wishes.
I hadn't thought about it that way before, but I can see it.
Bug is our resident philosopher.
This is the
Yeah.
thesis statement for the essay I will be writing for my mechanical engineering course that I will get a C- on.
Well,
I wish you good luck in getting that C-.
I was gonna say I admire your optimism, but
I have bullshitted my way through essays worse. I've gotten A's on essays about books I didn't read, so I can bullshit my way through an essay.
It's funny you mentioned pottery wheel because I got a C- in high school in ceramics. So
Your high school
Like-
had ceramics?
yeah, we had a
That's
ceramics
sick.
class, and it was like supposed to be an easy A, and I got a C- because I was so bad at it.
Wait, okay. I'm sorry. We're gonna
terrible.
pull over there. Emma, you grew up in Texas, right?
Uh-huh.
Wait, where in fucking Texas did you have a ceramics class? Because I grew up in Austin and we didn't have a fucking ceramics class.
It was in Dallas.
Dallas.
And
Fucking Dallas.
we didn't have like a woodworking class or anything, like you see in like high school. Like,
We didn't have that
movies,
either.
From like the 80s or 90s.
we had art.
In my high school in Maplewood, New Jersey, we did not have ceramics or woodworking, I think. I don't remember us having either of those.
We had a pottery wheel, and I made the most garbage fucking shit you would ever see.
What did you
It was so
make?
bad. I couldn't even.
It was
I
probably,
tried to make some bowls.
I was gonna say it was probably like bowls and stuff.
It was bowls.
That is kind of what you make out of ceramics.
And novelty toys. Out of whatever. Sorry,
Sure.
we gotta cut that. Don't put that in there. Do not put in the paper that I made dildos in high school.
out of ceramics, no less.
Yeah, that's
That
not
doesn't
body
sound
safe.
I have to-
comfortable.
That's not even like the least safe thing that I made for that purpose.
Okay.
Never mind.
We're
Sorry.
getting-
What am I doing? We gotta cut this in the last 5 minutes. This is
Emma,
derailing.
I'm not cutting any of this. I'm sorry.
No.
I'd
No.
love. It sounds like you were quite an engineer. I'd love to hear more about what you engineered.
A lot of problem solving happening.
For the audience at home, Emma just did a spit take.
I'm gonna sit in silence and shame for the next few minutes.
All right, what the hell was I talking about that I was gonna get a C- on the paper about? That was some bullshit. Never mind. That was some bullshit I was spitting about the philosophy of wonderment or some garbage. We were talking about engineering.
We sure were.
Where are we at with that?
Okay, so I think I talked to you about the V engine, right? And how
Yeah,
things.
yeah.
Yes.
Right.
Yes. Let's get back on track.
Right. So one of the uses of a rotary table is to make milled features like that at weird angles, right?
Okay, all right.
Another way that rotary tables kind of open things up once you add CNC to the mix is you can make a lot of parts faster if you have a rotary table. If you have some sort of simple part you need to make in a mill, and it takes you, X number of seconds to take that piece out of the mill, put on a new piece, run the operation again, take that piece out, do it again. What you can do is have your rotary table put on a big row of parts, and your CNC mill can do that operation on all these parts. Your rotary table can flip those. You'll have another row on it, they're called generally tombstones, and it'll be a large, sturdy piece of metal that you can put all your work pieces on. And however many you can fit into that machine, you can have them all done in one go with one program.
Is for mass production
Mhm.
of things, then is there a push to get for lack of a better term, bigger rotary tables or more capable rotary tables? So the more you can code ahead of time, the better.
Gotta get
Exactly.
rotoried up.
Exactly. Yeah, that's 100% how it is. Um, and how a rotary table is kind of the first thing that opens up your mill to faster production, more production, and as well as, different geometries of production.
Wow. Okay.
Okay.
That's awesome.
Mhm.
All right. So the rotary table makes mills at funny angles.
Right. Um, so far I've described if we have, you know, a rotary table that's flipping something along one axis, right? And you'll get your V in your engine, something like that. And so if this is happening and you've got a mill that only comes down in one direction and a table that only moves around side to side like that, um, you can only hit four sides of that part, right? You can only go all the way around it. Unless you put a rotary table onto another rotary table. So if you've got one axis spinning
What?
horizontally and you attach another
Holy
table
shit.
to that axis that spins like
My
a record
mind's
player,
blown.
right?
I did
So
not
now
see
you,
this coming.
mhm. So now you can tilt something and rotate it. You can rotate it while it's tilted, and now you can hit all the sides of the part at about any angle that you want.
You can rotate your rotary table to make weirder shaped rotary tables.
Exactly. Exactly.
Could they
Oh my
theoretically
gosh.
use this to make like a fifth dimensional rotary table?
So
Like
at
if
this
you
point,
stack
right?
like pi times pi rotary tables on top of each other.
Well, this is actually interesting when we start talking about like degrees of freedom. If I say like a degree of freedom, that has like a mathematical meaning, right?
Yeah, I mean I can think of some meanings for that, but nothing to do with math.
Well, like in the context of CNC, degree of freedom is going to sorry.
For the audience at home, Emma just did another spit take.
God damn it.
Anyways,
Continue.
rewinding a little bit. So you asked about putting like just another rotary table onto there, right?
Yeah.
Um,
Mm-hmm.
so a mill is typically going to move in three axes, right? You'll have a table that moves side to side, and a spindle that moves your tool that goes up and down. And so this is going to be your X, your Y, and your Z.
Okay.
Okay.
When people add a rotary table in the industry, that's called adding a fourth axis, because now there's something that you can rotate around, right?
Got it.
Okay.
When you add a rotary that's on that rotary table, there's your second one there, that's called a fifth axis.
Okay.
And what this already kind of does is let you hit all sides of the part at just about any angle. And from here, the greater constraint into how you can shape your part becomes how you attach that part to the rotary table. Because it's going to be, at some point attached to the table, and you can't go through the table to get there, right? So 5 axes lets you hit basically 5 sides of the part from any angle. And when people start adding axes at this point, they'll start making machine tools with more spindles, or it'll be like a lathe with a milling head on it. And this is sort of where all the crazy things start coming into it. But
What?
as right, so as far as adding rotary tables and rotary tables, um, two is about as far as it goes, and that's generally the most you'll need for most parts.
And if you get up to 6, then you can rotate time.
Time's rotating with or without anything. That's unfortunately
I'm really excited to learn that there are non-binary machine tools. Like that there are machine tools that can be a lathe and a mill.
Oh my
right.
god.
Like
I love that for them.
no, it's very funny because when I was putting together my notes, right, I'm like, okay, how am I going to explain the big two machine tools while still leaving, room for all of the breadth of machine tools out there? And I was on the fence about saying that like lathe and mill were the two genders of machine tool.
Oh my god.
And so
Because of
then
course,
there was a cringe joke available and I made it.
yeah, and so, it's important that the host makes that first.
Yeah,
True.
that's what I'm here for. To find the worst thing you can say and then say it.
One dumb question. What
Mhm.
for the stuff that I like, I mean, this is impossible to answer probably. Like the stuff that I see, like that I interact with on a daily basis, like a table or like a
Mhm.
bookshelf or a TV, like is it common to go like 5 axes with things? Is that like normal for stuff like that? Or like is
Ge-
that like rare?
Generally not, um because these machines start getting expensive, right? These machines
Okay.
start like getting precise. A lot of the things that we interact with are the things that are cheap to produce, and it's because they're cheap to produce that we end up interacting with them most. So for example, like that bookshelf behind you where it's got that, slab of particle board, fiberboard, whatever, with its pattern of holes, that's something called a one operation part, right? Where someone had to load that piece of wood into a machine, the machine made its holes, and then the piece of wood is done. That would be one operation, right?
Okay.
If it had to like get to something on the underside, or if you had to reposition that piece of wood in some way in the mill for it to be finished, those would be second or third operations, right?
Okay.
Okay.
So part of the magic of the rotary table is that it turns something that might be a multi-operation part if you can only put it down one certain way in your mill at a time into something you only have to put on a rotary table once.
Okay.
Got it. Got
So
it. Okay.
right, so for a part that needed 5 axes to create, you probably wouldn't see one very often in real life, but every time you fly on a plane, there would be so many pieces in that jet engine that were made on a 5 axis mill.
Ooh, why planes?
So planes have jet engines, right? This is just the first example that comes to mind of something that I know like really uses this often. But there's, it needs to be compact, it needs to be lightweight, it needs to get up in the air. And so to make that design, if you need to have a bunch of ports for fuel and stuff coming in at crazy directions, it makes sense to invest in a 5 axis machine that makes that possible. That might also be the only way it works. Also, for something like uh, a turbine inside that plane, if you need to finish that machined surface to make a nice smooth surface for your turbine, I know there's a difference between turbine and turbine, and I'm not sure when that difference comes in. So someone might even, correct and say like, actually, in the jet engine context, it's turbine. But if you can sort of imagine that like spinning part with curved little blades coming off of it, a five
Uh-huh.
axis mill allows you to get your tool in at exactly the angle that matches along all of those curved blades and do it precisely every single time for every blade.
Got it. Okay. Okay. So like the more
Mhm.
where like failure is not an option, you want to have like very complex things, like a jet engine.
Right, right. Where there's no room for like dumbing something down like a bookcase. That's where you're going to find
Got it.
this sort of thing.
Got it. Okay. That makes sense. I have a lot of IKEA furniture, so I probably
Oh
have a lot
yeah.
of very simple
Uh-huh.
simple things.
We're coming up on the hour mark. I think that it is
Mhm.
time for us to move into what is, I think, going to be truly the most make or break what we've learned segment on this podcast yet. So, Emma, what have you learned today?
Okay, legitimately, I did not know about lanes and mills at all, and like the two main types of machines, and I will now think much more like legitimately, I will think much more closely about like how something is made, and it has made me more curious about the world that I interact with, and that is really fucking cool. So like that's awesome. I also learned that like acronyms are just not consistent across different groups, and that was wild to learn also.
I learned that the field of mechanical engineering is full of a lot of himpos into CNC. I learned I learned that you can use engineering to control time. And I also learned that Emma made play dildos in high school.
Oh my god, why would you put that as the kicker at the end?
No, I can't cut it out.
Hearing what we have learned, Quinnie, do you feel like you've successfully thought like a bimbo enough to explain your area of expertise to us today?
I think so. I mean, I said going into this that I was aiming to do bimbo outreach, and I think just giving you that little bit of information to understand the world around you more completely and have, a place of curiosity to start learning about this or something to relate the things you learn more back to it. I'm happy. This was great.
Yay, I'm glad. I'm glad that that was your takeaway, and I'm glad that we can move forward with a little bit more curiosity about how the things around us are made, because I do genuinely think that that is very neat, and that you don't necessarily have to like have a full understanding of these things to appreciate them. And I think that it is always worth thinking about how the things around you come to be and remembering that somebody's passion went into making that. And I think caring about passion and caring about like how the world around you operates and how everybody works together to make the world, even when you don't understand it, is bimbo mentality, baby. And I think that's what we're here to understand. Quinnie, do you have anything? I know this is sort of a strange question for a sort of professional, but do you have anything you would like to plug for us? Any new rotary tables on the market?
Yeah. No, it's okay.
Well, it has been an absolute blast having you here. This was a really cool, fun, exciting thing to learn about.
This was so fun. Seriously, I learned so much.
Also, I mean, the other side of that coin is that like having the opportunity to do something like this makes my job more fun, right? It's fun to go to work and do the same shit I do every day if I get to like talk about it with bimbos later.
That's a great point.
That's excellent.
That's a great point. That's the service that we provide, Emma. And since Quinnie did join us as a pitch, I will remind all our audience out there that you can pitch to be on the pod if there is something cool that you do and that you think you would have fun teaching about us. So you can DM us on our Blue Sky or Instagram accounts, or you can email me directly at prettybug@proton.me. I think that is gonna do it for us this week on Bimbo Mentality. Tune in next week when we talk about poetry.
Death